Hello, my name is Kirthana Kumar, and this is my lab report for Lab 2, Lines of Charge. The purpose of this lab is to visualize the tape from the first experiment as a line or rod of point of charges rather than one-point charge. This can in turn affect the charge of each of the tapes. From the point charge model in Lab 1, the charge of each tape was observed to be 3.49 times 10 to the negative 7. And from the model in Lab 2, the charge of each tape was calculated to be about 3.55 times 10 to the negative 7, with the simulation being way more accurate using a 1.92 times 10 to the negative 8 charge measurement. So the main physics ideas used in this lab were the same as Lab 1, so it's Newton's second law and Coulomb's law. Newton's second law describes the concept of F net equals mass times acceleration, which is used in this experiment to calculate gravitational force on the tape. And Coulomb's law is a formula used to calculate the amount of force between two charged particles, which is shown here, where K is a constant and equals 9 times 10 to the 9th, and Q1 and Q2 are point charges, and R is the distance from the observation location to the particle. So for a review of Lab 1, our system was the bottom tape, and the tape mass was 0.07 grams and 0.07 meters, and the surroundings was the top tape and everything else. So it is the opposite of what the diagram is showing, with our system, us lowering the top tape onto the bottom tape. And the distance we found to feel the electric force was 0.04 meters between the tape. And using Coulomb's formula and solving for Q, we saw the particle charge as equal to 3.49 times 10 to the negative 7. So due to Newton's second law, the force of gravity is equal to mass times acceleration, or in this case, Fg equals mg. And since the net force of the particle equals 0, the magnitude of the gravitational and electric force must be the same. However, each point along the line or rod has its own gravitational force and electric force acting on it, which requires a different equation or model shown here, which is Coulomb's law for a rod. So using this formula and solving for Q, we calculated the charge to be 3.55 times 10 to the negative 7. So in the coding portion, we can see here that 3.55 times 10 to the negative 7 was used. However, when doing the modeling, it displayed that the magnitude of electric and gravitational forces were not equal at all. And so using guess and check, we found that this charge, 1.92 times 10 to the negative 8, was more representative of an equal magnitude of electric force and gravitational force, as can be seen in this model. This piece of code here is a for loop or an iteration calculating each point charge's electric field along the tape, along with the electric force of each point charge, and summing it up. So each green arrow shown here is the electric field of each individual point charge along the tape, and the white arrow is the electric force shown by each point charge of the tape summed together, and the yellow arrow is the gravitational force on the tape. And this is the piece of code that calculated the green arrows, or the E field, of each point charge. So the charge calculated for the second lab is around the same as the first lab. However, when simulating the model, it required a much lower amount of charge per point. It's important to note that in this computational model, there is no air resistance or drag, and the tape is represented by multiple point charges. Some assumptions: each piece of tape had the same charge, and it was pretty evenly distributed during the experiment, and the mass of 1 meter of tape is equal to around 1 gram. Possible sources of error include incorrect handling of tape, which results in loss of charge, repeating the experiment multiple times with the same tape pieces, which could result in a overall less charge or less dramatic result, lack of precision when measuring distance, and the only forces in the surroundings being considered were electrical and gravitational forces. So the charge for the point charge model was around 3.49 times 10 to the negative 7, whereas the line charge model calculation was around 3.55 times 10 to the negative 7. However, it should be noted that in the simulation, in order for the electric and gravitational forces to be closer in magnitude, the electric charge of each point on the tape had to be much lower, around 1.92 times 10 to the negative 8. This may be due to an error in measuring distance during the initial experiment. These estimates differ because the point charge formula treats the tape as one large general point to calculate, whereas the line charge uses multiple different charges from each point along the tape and sums them together. The line charge is most likely closer to the real value because it represents reality more accurately, with smaller points along the line distributing charge rather than one large point in the middle.